AI Portal number 16. Today we're going to look at AI-generated GARCH volatility forecasting models. We can go into financial applications, we'll do a GARCH analysis, and we're going to look at Apple's historical volatility and use it to predict the next 10 days. So let's go back to 2023-01-01, and we're going to end it on, let's end it 2 days ago, which would make it March 10th, 2025. The GARCH parameters, we're going to leave these at 1 and 1. We saw the ARIMA model a couple days ago, and this is the same P and the same Q, and we're going to leave this to the statisticians and the experts that actually do this, because we're not trying to tread, and we don't do statistics like that. Our forecast horizon is 10 days, and the language model has produced a nice model for us. And if you zoom in over there, we can actually pull these numbers out. It expects the next iterations, the forecasted volatility, to be rather flat. So here we can see the historical patterns here, and from this historical patterns, the GARCH model determines what the forecasted volatility is going to be. And over here on this scale here, these are the sigma values. Now these are important to us as ML engineers, because we want to grab these values and pass them on to Black-Scholes, or the value at risk in a Monte Carlo model. Let's go over here and look at another model that we made. Here's our GARCH back testing tool here. We use NumPy and Pandas, Yahoo Finance, to get the data there. And in our auto-generated code here, not auto-generated, but then the AI-generated code, it included this little hiccup here. And there's a couple little things that you have to massage whenever the AI generates code for you, and you have to know how each of these steps work. This is the actual mechanics of the GARCH model. Here's where a plot is made, and we determine the sticker, or the ticker, that we're going to use, and we give it the start date and end date, and it plots for us the predicted volatility and the actual volatility. And then we have the mean average error, so that we can determine whether or not this model is going to be sufficient for feeding it to support the other models, such as the Monte Carlo model and the Black-Scholes model, which is of particular interest to me. Make no mistake, the future of coding is cleaning up from AI-generated code. It can write 50 lines before you and I can type a single line of code. So when we refine our backtesting tool, we probably want to put some dates down here. This is just giving us the record count, starting back to the first date of January 1st, 2020. And here we just have a simple scale. This does not give us a sigma value. And we need the sigma values, again, to feed this into the other models. So here's a desktop version here, and it's expecting the volatility rate to go down on SPY. But it would be nice to be able to get these analytics for 10 or even 100 or even 1,000 of different asset models, and that's what we're going to build up to. Just want to take a quick look here at a couple GARCH charts that I snipped out of here. We have our tenths, hundreds, and thousandths, the volatility here, and it spikes one day. Back in September, we saw this in a previous video. And over here on SPY, we have our tenths, hundreds, and thousandths. And maybe we see a pattern in here, and a big spike there. And then over here at J&J, Johnson & Johnson's, we have our tenths, hundreds, thousandths. And then we have the 10,000ths and the 100,000ths. So and what I'm getting at is that the scale of this movement is very small for J&J, which means that it's not the asset is less volatile than these other ones. And so for our ML engineers that may not be as familiar with financial forecasting, you need these kind of things to help us get up to speed. That's going to be of great help when we look at building hundreds and thousands of these forecasts and feeding them into our large models. Thank you for your time.